Hello AP Chemistry and welcome to a qualitative discussion of thermodynamic favorability. Okay, so previously we talked about, obviously we can calculate the standard heat, we can calculate the enthalpy of a process using either calorimetry or Hess's law or standard heats of formation. We can calculate the entropy of a process using standard molar entropies. Okay, and using this we can calculate the delta G of a process. Now, we also said that negative delta G's are thermodynamically favorable, meaning that this process is likely to happen as written. Okay? Now, sometimes we don't actually want to talk about numbers. Sometimes we just want to talk about qualitatively, is this a thermodynamically favorable process or not? So, we understand that thermodynamically favorable means a negative delta G value. Okay? Now, what is a favorable delta H value? Right, positive. No, my bad. Negative. Negative, because negative means it's exothermic, right? Energy is released, and again, that is a good thing, right? That is a favorable thing for reactions, right? And likewise, originally, this was thought to be what determines whether or not a reaction occurs. We know that entropy is favorable if it is doing what? Right, increasing, right? Temperature is always going to be what kind of a value, by the way? Right, it's always going to be positive because this is always going to be in Kelvin, okay? So what that means is if this term is favorable, if my enthalpy term is favorable and my entropy term is favorable, then I am always going to have a negative delta G, okay? Meaning that my process is thermodynamically favorable at all temperatures, okay? Now, let's talk about another scenario. Let's talk about what happens if delta H is negative or positive, meaning unfavorable. If this is negative, meaning unfavorable, right? Now, if this is positive and we minus a minus, that means my answer for delta G is always going to be positive, right? Which means that if my enthalpy term is unfavorable and my entropy term is unfavorable, delta G is thermodynamically unfavorable at all temperatures. Yes? So these are our two always conditions, right? If both terms are favorable, then my delta G is always favorable, okay? If both terms are unfavorable, my delta G is always unfavorable. And then we have our two in-between positions, okay? Wherein we could have a negative here and a negative here. So we would say that this is enthalpically favorable. We would say that based on our entropy term, it is unfavorable. What does that mean over here? So let's ponder. If this value is negative, this value is negative, what do we need to happen in this case? In order for delta G to be negative, what needs to happen? Let's put some more parameters on this. Right, if we say minus a minus, that means it's a positive, right? That means we're adding, right? So what that means is that my absolute value of delta H has to be greater than the absolute value of my T delta S. Yes, does that make sense? As long as the absolute value of this is greater than the absolute value of this, then it will be favorable, which means that this is favorable at low temperatures. Okay, favorable at low temperatures, where my enthalpy term is not as important, right? Because as long as I can keep this whole thing relatively small, smaller than this, I'm still going to come up with a negative value here, okay? Point of reference, if this is unfavorable, but this happens to be favorable, okay, now what happens? Right, this is a positive value. This one is going to be where our negative comes from, which means that in this instance, I need for my absolute value of delta H to be less than the absolute value of my T delta S, right? Which means that this is spontaneous at high temperatures. Yes? Yes? All right. Take a moment, look at this, ponder it, and make sure it makes sense to you. Okay? It's really, really important because some of our questions are obviously going to be quantitative, right? Calculate these numbers. Is it favorable, yes or no? But a lot of them are just thought exercises, right, that are asking you to discuss whether something is likely to be favorable or not based on things that we know. Okay? All right, so make sure you understand this, and I think we'll pause here and move on to the next one. All right, be good. Thanks for listening. Bye.